Let's continue our discussion about theorem. Theorem number 8, De Morgan's theorem. De Morgan's theorem is used when we want to separate the negation among the variables under one negation. Or if we have separate negation, we want to have a shared negation, we could also use De Morgan theorem or theorem number 8. So we have two forms. So not of A plus B is the same as A not B not. Not of AB is the same as A naught plus B naught. So how do we implement the Morgan's theorem? Okay, first step, we need to determine the variables under the not negation or negation or complement operation. So we have AB here, just copy AB from or to and to or, and then distribute the negation among the variables. That will be our answer when we implement De Morgan's theorem. So for example, not of A plus BC, we want to separate the negation between these terms A and BC. Okay, using form A, so we have A naught and it to be C naught. So again, copy A, copy BC from or to and then separate negation. If we want to separate BC to have a separate negation, we could also implement De Morgan's theorem using form B. Okay, so the result will be A naught and to B naught plus C naught. Okay, so how do we get this? Copy first and to or and then separate the negation. That will be our answer. Okay, and again, this is not the same. A naught of A plus BC is not the same as A naught B naught plus C naught. Don't forget that. Okay. A naught B naught is not the same as naught of AB. Okay. Another example. Another example in implementing theorem number 8. We have naught of A added to B or C added to C x plus A naught. Okay, so we have multiple grouping and all the whole equation is negated. So if we have this type of equation, it's somehow complex, we need to determine what variable is A and what will be our B. Okay, so this will be our A, which is A, and then B plus X, this second part will be our B. Okay, so when we implement the second form, this and will become or, separate the negation, one for A and for this term. And in case we want to separate the negation between this term, we could implement again form A. Okay, so B plus this term. Okay, so the result will be A naught plus B naught ANDed. So or will become and, separate the negation. We have B naught and naught of this. And again, in case we want to implement negation here, so the first variable will be C and the second variable will be X plus A naught. So implement and will become or, separate negation. And still we have a common negation here. So we could implement form A. Okay. So now or will become and, separate the negation between variables. Okay. And this will be our answer. Okay. Theorem number 9, consensus. So AB plus A naught C plus BC is equal to AB plus A naught C. Second form, A plus B plus A naught plus C added to B plus C is the same as A plus B added to A naught plus C. So by analyzing the given, so one term is removed from the left side. So here, BC was removed, and form B, B plus C is removed. So how could we determine if theorem number 9 can be implemented? So first step, locate four complemented variables between two terms, and then inspect the variables added to it, which are B, C. And if another term contains it under AND operation, that term could be removed to get the simplified equation. Okay? Form B, same procedure. Locate four complemented variables. Inspect the variables or to it. Is it present on another term under OR operation? Yes. And that term will be removed to get the simplified equation. So that's consensus. Okay? So let's have an example. We have AB plus A naught CD plus BCD. So let's implement theorem number 9 for the first two terms. Do we have complemented variable? Yes, A naught. And the variables added to it, B, C, D, is it present on the third term? Yes. So remove the third term, and the result will be AB plus A naught CD. So this will be our final answer. Another example, ABC plus A naught D plus A naught D plus B naught D plus CD. So let's consider the first two terms. Okay? But before that, we could factor out D first, and then De Morgan's. And as you can see, not of AB is the negation of AB. And added to it, CD is present on the third term. Therefore, the third term could be removed. So we have this answer. Okay? So that's it for the theorems. Next video lecture, we're going to discuss the standard format, how to write our final answer. Okay? See you on the next video lecture.